Hello students, today we're going to solve question 3 from GATE CSE 2029. The question states that two cars start at the same time. Okay, they are starting from the same point of time, okay, from the same location is also same, and go in the same direction. Okay, so the point from which they start, the time at which they start, and the direction in which they start are the same. Okay, the speed of the first car is given to be 50 kilometers per hour. Very good. This is V1. This represents the speed of the first car. This one is the index representing the first car. The speed of the second car is 60 kilometers per hour. The number of hours it takes for the distance between the two cars to become 20 kilometers is. Okay, so we have to calculate the time. Basically, we have to calculate the time in hours. Right, in hours we have to calculate the time in which the distance between the two cars becomes 20 kilometers. Right, they are moving at the same direction with this, but their speeds are different. The velocity of the second car is 60 kilometers and the velocity of the first car is 50 kilometers. So after some time the second car is going to be ahead of the first car, right? And how much amount is the second car has to be ahead for us to record the answer, the time? That is going to be equal to 20 kilometers. Okay, now there are two methods to solve this, because first is to directly apply the time into this speed and calculate, because this 20 kilometers is something that has to be achieved, and the difference between the velocities is quite apparently 10 kilometers per hour, right? Because 60 minus 50 is 10. Right? So if I were to calculate after 1 hour, the velocity of 1 is going to yield the first car a distance of 50 kilometers. The velocity of 2, okay, why it is not written 2 over here, this is wrong. The velocity of 2 is going to yield it 60 kilometers. The difference in both of the cars in terms of distance is going to be 10 kilometers. Very good. We want 20 kilometers. So right now we have not achieved our aim, our difference, right? One hour is not sufficient. So let's apply the second hour. Okay. So at the end of the second hour, the first car is going to be traveling 100 kilometers. Why? 50 times 2 is equals to 100. Very good. At the end of your second hour, the second car is going to travel 120 kilometers. Why? 60 times 2. 60 times 2 is the difference between these two. The distances that they have traveled is equals to 20 kilometers, and that is the desired distance. So, and at this desired distance, we have to record the time, and that time is your answer, right? So you got your answer. So directly mark the option B, because it is having the quantity 2, and this 2 hours is exactly what we have to calculate, right? I know this gave you the answer, but as it was a aptitude type question, and in this particular question that they have framed, analyzing it directly gives you the answer very quickly. I know, but there is no guarantee that you will get answers this quickly every time. So it is always better to solve such questions from an analytical point of view, right? So I'm going to give you the analytical analysis so that you can have that with you when you face such questions in the examination, right? Okay, so let's view at the question one more time, right? So we know that 50 kilometers is the velocity of V1, right? We know that 60 kilometers is the velocity of V2, right? Now one more thing that we have, you must have heard till now, is the concept of relativity, right? Relativity, right? So relative to the first car, the second car is moving at 10 kilometers per hour. Relative to the first car is at rest, right? I hope that you understand this concept. If you don't, then just look up on YouTube regarding relativity and speed dynamics kind of questions. It's kind of a 9th-10th physics kind of questions which came 9th-10th class, right? So from that point of view, because the direction is exactly the same, right? So the absolute velocities are 50 kilometers and 60 kilometers. I know that. But relative to V1, the V2's velocity is 10 kilometers, right? Once we have the relative velocity, right, for the distance for 20 kilometers, because first one is at rest and the second one is only moving at the velocity of 10 kilometers relatively, and what we have to achieve is 20 kilometers. Just directly divide 20 by the relative velocity. That is going to give you the amount of time it is going to take for the two objects to travel so much that the distance between them is amounting to 20 kilometers. Very simple, directly forward and analytical. No, we don't have to check for every hour. You can directly apply the formula and then you can get 20 by 10, which is going to give you 2 hours. The same thing which we got from direct active experimentation with putting the time t 1, then 2, then 3. It is much better to do it this way, analytically, right? And I do hope that you appreciate that the importance of solving questions analytically and then solving them by brute force, because applying 1 and 2 and then 3 hours is brute force. This is analytical, and analytical always beats brute force in all terms, right? And with that, you will, I think that you understand it, and I am assuming that you must have been able to solve it by yourself, and this video only serves as a validation for the solution which you got by yourself independently. With that, I will see you in the next video. Thanks for watching.